content for this online briefing. So I will give you some introduction and theory. But before that, I will tell you what is the experimental outcome and objective. I will introduce you all the apparatus. I will tell you what to do, the procedure, and then I will tell you how to do the data collection. All right. So the experiment outcome. So for the experiment, we are going to determine the ionization potential for xenon and argon. Okay, and we also want to show the existence of dystaric energy level of the xenon atom, and then we also want to determine the first excitation level for xenon. Okay, so these are the experiment outcome. So the title is ionization and excitation potential. So what is ionization? Ionization in chemistry and physics, any process in which electrical neutral atom or molecule are converted to electrically charged atom or molecules or ions. Ionization is one of the principal ways that radiation such as charged particle and X-ray transfer its energy to matter. Okay, I can make it simple. Let's say you have Cl atom, or you have sodium atom, okay, Na. Sodium atom have one valence electron, okay? So when it donate or throw away one valence electron, then it will become Na+. Okay, Cl has 7 valence electron. When it accept one electron, it becomes Cl-. Okay, so the process of converting the atom into ion, we call it ionization. Okay, so atom cannot flow in the circuit. Okay, atom cannot flow in the circuit, but positive charged anion sodium and negatively charged sorry, this is cation, this is anion, and cation sodium and anion chlorine can flow in the circuit. Okay, so ionization basically converts a neutral atom like Na into Na+, the charged ion. Okay, the neutral atom cannot flow in the circuit, but the charged ion can flow in the circuit. For excitation, the definition for excitation in physics, the additional of discrete amount of energy, we call that excitation energy, to a system such as atomic nucleus, an atom or a molecule that result in its alteration, ordinarily from the condition of lowest energy, we call it ground state, to one of the higher energy, we call it excited state. So when the atom, when the electron that locate on the ground state or on the lower state, any lower state, when it gain the energy and then it excite to higher state, we call this process excitation. Okay. So the objective for this experiment, the first objective is to determine the ionization potential of xenon. The second objective is to determine the ionization potential of argon. Okay, basically experiment 1 and 2 are very similar. The only difference is that we use different gases. Okay, first experiment we use xenon, second experiment we use argon. And we want to know what is the potential that required to ionize the argon atom into ion argon, or to ionize the xenon atom, which is neutral, to charge ion. Okay, so we want to know what is the potential that required. Then for the third experiment, there are two objectives. The second one is similar to the objective 1 and 2 to determine the first ionization potential of xenon. And then for the first objective of the third objective is to show the existence of the discrete energy level of the xenon atom. Okay, so the first objective corresponds to the first experiment, the second objective corresponds to the second experiment, and the third objective corresponds to the third experiment. So there will be 3 experiments for this 1MP2. Okay, introduction and theory. So in the early part of the 20th century, the structure of atom was studied in depth. In the process of developing and refining a theory of atomic structure, scientists developed a number of theories and techniques designed to explain and investigate experimental atomic phenomena. Scientists have developed a periodic table of the known elements without realizing the part that the structure of atom play in placing an element in that table. It has been found that atoms are related to electromagnetic phenomena, since molecules could be dissociated into their component elements by applying a current to them. So the differences among magnetic, insulating, and conducting materials were suspected to be related to atomic structure. Heated elements emitted light when a current passed through them. The light emitted by element is at specific frequency, which indicate a characteristic internal structure specific to each element. Therefore, in 1897, J.J. Thomson had developed a technique to deflect charged particles through the magnetic field. This technique provides indication about the charge to mass ratio and sign of the charge of an electron. In 1909 years, Ernest Rutherford Hahn Jaeger and Ernest Marsden developed scattering experiment to probe the internal charge and mass distribution of atoms. In 1915, Niels Bohr developed mathematical technique for predicting the atomic behavior that incorporated to the new idea of quantization and correlated to experimental analysis of the wavelength spectrum of hydrogen. So the state of the lowest internal energy of an atom is called the ground state. And the energy of this state can be denoted by E0. Okay, and then E1 is the energy of the first excited state, E2 is the energy of the second excited state, and so forth and so on. The atom cannot exist with an energy intermediate between E0 and E1. It must be located at either E0 or E1. It cannot be located between these two levels, or E1 and E2, so forth and so on. So E infinity is the energy of the ionized atom, for the example, an atom with an electron removed completely from it. For region, which will become clearer later, E1, E2, E3 are called the excitation potential, and the E infinity is the ionization potential of an atom when they are expressed as electron volt. The atom will normally exist in the state of lowest energy, for example, the ground state. To raise it from the ground state to the first excited state, an amount of energy E1 minus E0 must be supplied. In the case of atom in a gas, this energy must come from the kinetic energy of the atom, which could become internal energy in a collision. The mean kinetic energy of an atom in a gas at temperature T is given as the mean kinetic energy equal to 3 over 2 kT or kBT. Boltzmann constant kB. This form the basics of the present experiment, which was first performed by Franz and Hertz in 1914. And it's an experimental verification of the fact that the internal energy of an atom is quantized. Okay, so these are all the introduction and theory. Next, I'll proceed to the apparatus. Okay, I will introduce you all the apparatus. Okay, like what I mentioned previously, we'll use two types of the gases. The first one is the xenon, and the second one is the argon. Therefore, we prepare two Teratron 2D12, something like this, a small box. Okay, and we have two plugs. The first one is the small one. This is a small tube. Small tube contain of xenon gas, and the other one is a larger tube. It contain of the argon gas. Okay, so the small tube will be required for experiment 1 and experiment 3, and the larger tube, the argon gas, is required for experiment 2. Okay, don't use the wrong gas lah. If for experiment 1 you use the larger one, use the argon, then I will consider it as one mistake. Okay, so then I will deduct your 6 point. So the Teratron. The Teratron is a type of the gas-filled tube use a high energy electrical switch and control rectifier. Because of the gas fill, Teratron can handle much greater current than similar hard vacuum or tube, since the positive ion carry considerable current. Gases used in this experiment include the xenon and argon, two types. So unlike a vacuum tube, a Teratron cannot be used to amplify signal linearly. Okay, so this is a small tube contain of xenon gas, and this is a large tube contain of argon gas. Okay, when you view on this box, the Teratron base, you can see that we have 1, 2, 3, 4, 5, 6 connection hole. And you can see that you have there's a label there, G A K K H H. Okay, A G K A H H. Okay, the A stand for anode, G stand for gray, K stand for cathode, H. This H should be connected to the multi-state transformer. All right. So what is argon? What is xenon? Argon is a chemical element with the symbol of Ar, and the atomic number is 18. And then xenon is a chemical element with the symbol Fe and the atomic number of 54. Okay. How to connect the, okay, I think this is the wrong title. So we have xenon, we have argon. Okay, xenon will be used for experiment 1 and 3, 1 and 3, and then argon will be used for experiment 2. Okay, then xenon look like this, smaller tube, and then argon look like this, larger tube. Okay, don't mess it up. All right. Okay, the second apparatus that I want to introduce is the adjustable register. So this register will be used for all experiment 1, 2, and 3. What is a register? The register is a passive electrical component to create resistance in the flow of electric current. In almost all electrical network and electronic circuit, they can be found, right? So the resistance is measured in ohms, And ohms is the resistance that occurs when a current of 1 ampere pass through a resistor with 1 volt drop across each terminal. Okay, so the resistors look like this, right? So we have 3 connections, side 1, 2, and 3. Resistor does not have any terminal. Okay, resistor does not have any terminal. So you can connect the positive here, negative here, or vice versa. You can connect the positive here, negative here, doesn't matter. Okay, so it means that you have positive, negative wire, you connect it to this point, positive wire, you connect it to this point. It's all right. Or you can connect in other way, positive to this point, negative to this point, also can, no problem. Okay, but you cannot connect both positive and negative to this point. Why? Because the resistors work like this. When I connect positive here, I go in, negative out. Okay, if you connect both positive and negative here, then it will in, then out, without go through this resistor. Then you will get 0 ohms, no matter what reading that you are setting here. Okay. So when you look at this resistor, you can see that here's ohm times 10, ohm times 100, 1000, 10,000, 100. Or when you magnify, you can see that ohm times 10, 100, 1000. Right. So let's say you want to get 100 ohm. Then ohm times 10, you have to set it to 0. Set it to 0. Then 100, you have to set it to 1. Okay, you have to set it to 1. Then 1000, you have to set it to 0. And so far and so on. If you want to set it to 1000 ohm, then this one, times 10 one, you have to set it to 0. Times 100 one, you have to set it to 0. And then for 1000 one, you have to set it to 1. Okay, then you will get 1000 ohm. So this is the adjustable resistor. Okay, for power supply, this is the third instrument. The power supply will be used for all 3 experiments. A power supply is an electrical device that supplies electrical power to an electrical load. The primary function of the power supply is to convert the electric current from the source to the correct voltage, current, and frequency to power the load. Okay, so we have 2 types of the power supply. Okay, so you see here we have red, green, and black, 3 color, right? So the power button for the power supply is this one. So you have to push it to turn on the power supply. And then for second time, you have to push this button to turn on the power supply. Okay, I'll explain through this one. Okay, this is to turn it on. Okay, power. Then we know that we have positive and negative terminal, right? So the red color one means positive, the black color one means negative. So the positive terminal have to be connected to this red color one. The negative terminal wire have to connect it to the negative, the black one. Okay, same thing apply to this type of the power supply. Positive, negative. Okay. Then you just have to rotate or turn these 2 buttons, then to increase the voltage. Okay, for this is for the smaller scale, this is for the larger scale. And then for this type of power supply also, you have to observe this one. So this one can do can supply to one set of instrument, but this one can supply to two set of instrument. Therefore, it has two set of the button. So if you want to use both set, but normally you only use one set of the power supply. So if you only use one set of power supply, then you have to follow this one lah. If you want to use the independent, then both have to you have to release the button lah. So if you want to use it in series, then you have to one down, one up. If you want to use it parallel, then both have to press it. Okay. So if you want to use this set of the power supply, then connect the positive to this point, negative to this point. Okay. Then you have done the voltage, then you can see the reading here. Okay, and make sure you set this one lah. Then of course, if you want to use this set, then you connect the wire to here lah. Okay, you can use either one. Okay, multi-tape transformer. Multi-tape transformer is a step up or step down transformer that has multiple tape on either the primary winding or the secondary winding. The multi-tape transformer provides flexibility in your input and output voltage requirement. So in this experiment, the multi-tape transformer are used in heating elements application. The resistance of the heating element increase with age, which result in reduced current through the heating elements. Okay, the on-off button of this multi-tape transformer are on the back side. Okay, button, make sure you on it. Okay, make sure you on it. Then the wire for this multi-tape transformer have to be connected to AC current. Okay, AC current. So multi-tape transformer also have no terminal, so you can connect positive here, negative here doesn't matter, or negative here, positive here doesn't matter. Okay, so you connect to this AC, not DC. Okay, AC. And then you can also set the voltage for this multi-tape transformer. Like experiment 1 and 2, you have to use 6 volt, then just pull it out, and then plug it into 6 volt. Okay, if you want to use forward, then you just pull it out and plug into forward. Okay, this is how we set the multi-tape transformer. Okay, the voltmeter will be used for all experiments. A voltmeter is an instrument used for measuring the electrical potential difference between 2 points in an electrical circuit. So analog voltage voltmeter move a pointer across a scale in proportional to the voltage of the circuit. Okay, this is how the voltmeter look like. And of course, beside voltmeter, we have milliammeter. Okay, they look similar, but only with different scale. Okay, they look similar, and how they connect and how to read the milliammeter and voltmeter also almost the same. Milliammeter will only be used for experiment 2. For experiment 1 and 3, we use picoammeter. Okay, what is ammeter? An ammeter is a measuring instrument used to measure the current in a circuit. Electric current are measured in ampere, hence the names. Instrument used to measure smaller current in the milliampere or microampere range are designated as milliammeter. Okay. So how to read and connect a milliammeter? Okay, this is quite simple. We know that the wire got positive and negative terminal, right? So the positive terminal of the wire always connect to this. You see the positive here. Okay, you see the positive here. the positive wires always connect to this one. And then negative wire, you can connect to any number here. 10, 30, 100, 300, or 1000. Okay. Which one should you choose? Okay, this is the issue. Let's say if you choose 1000, so the net positive. Okay, for the first scenario, positive, you connect to this one. Negative, you connect to 1000. Okay, that means that the maximum reading will be 1000. Okay, you observe here. So here I have two group of the reading. The first group start from 1, 10, 100, and 1000. Okay, if you start from 1, then you read the upper scale. Okay, second group, 30, 300. Start from 3. If you start from 3, then you read the lower scale. Okay, same thing apply to the voltmeter. Okay. So now the scenario is, if you connect to negative to 1000, then of course you need to read the upper scale, right? So the maximum is 1000. If you connect to 100, then you still have to read the upper scale, but this reading change to 100. This reading change to 80. This reading change to 60. This reading change to 40. 20, 0. But still upper scale. If you're positive, or if you're negative, terminal is connected to 10. Then this side to change to 10. 8, 6, 4, 2. Okay, right. Okay, now I give you a scenario. Positive, I connect to this one, no issue. Negative, I connect to 30. And then this is point to, let's say, this point. So what's the reading? What's the reading? So I have to think in this way. See, we connect to 30. 30 means that I have to read the lower scale, right? I have to read the lower scale. And then the maximum is 30. So this I have to change to 30, 25, 20, 15, 10, 5, 0. So this point would be 12.5. Okay, so if you point to this is 12.5 milliampere. Okay, this is not 400. Okay, I hope this is clear. Okay, so just now I said that we have two types of the ammeter. The first one is the milliammeter, which will be used for experiment 2. And the second one is a picoammeter. Okay, and this will be used for experiment 1 and 3. What is picoammeter? Picoammeter allow making current measurement with high accuracy, even in the circuit with very low source voltage. Previously, milliammeter can read up to milli. Okay, but picoammeter can read up to pico. Pico is 10 power negative 12. Okay, it is very, 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 very sensitive. It's even more sensitive than nanoscale. Nanoscale 10 power negative 9 only. And therefore, this instrument is very, 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 very expensive. Okay, if you want to know how much it costs, you can search online. Okay, this 6485 picoammeter, and then you can search for the price. I believe that you will shock or you will be surprised with the price. Okay, very, very expensive. So how to use the picoammeter? Okay, you just push this button to turn it on. Okay, after you turn it on, you'll see something like this. Okay, you'll see something like this on this screen. Okay, something like this. So we have two types of picoammeter. The first type, we have 6 digit, 0.00. The other type is the older one. We only have 0.00. Okay, doesn't matter. Both pico ammeter can fit in our objective, doesn't matter. No matter which one you use, it's okay. Okay. So I just explain because they are just same, so I will explain the 6-digit one lah. How to read it? So this is 0.000. This symbol means micro. Okay, it will have three. One is N means milli. Another one is N means nano. Okay, so if the reading here show is 0.0, sorry, if the reading show here is, let's say 002.156 and then NA, it means that 2.156 nano ampere. Okay, if this symbol is something like this, give me micro, then this is 2.156 micro ampere. Okay, so when you start the pico ammeter, you see something like this. Okay, the reading and then the unit. But here you get one extra thing here, Jack C. Jack C means zero correction. Okay, when you see any reading after the unit appear, then you just press these two buttons. Okay, with random, you just press these two buttons, like press JACK-CHK, JACK-COR again, and so on, and press again, then until this JACK-C disappear, and it shows something like this. That means that you have done the zero check and zero correction. So now this pico ammeter is ready to be used. Okay. So when you increase the voltage, then the current also increase. Then when you see the word like overflow, then you have to press up or down to change it to higher range. Okay. Let's say when you push up or down, then the decimal point will move to here, move to here, move to here, then become nano ampere. Okay, you change to like 0.00 nano ampere. Okay, but if the reading is more than 999.99 nano ampere, then it will show overflow. Then you just press up or down to change it to the higher units here. Then now it's showing micro ampere. Okay, so you just press up or down when you see the word overflow. Then you change the unit to higher scale. Okay, let's say for this, you can see that this is the maximum value that you can show here is 999.999 micro ampere. If you have 1000 micro ampere, if the reading is 1000 micro ampere, then will show overflow. That means that you cannot use because okay, you can see here, you have the maximum reading that can be shown here by using this micro ampere is 999.999, right? But now let's say you have 1000 micro ampere, then it will show overflow. What to do? You just press these two buttons to change this micro to milli. So if it's milli, then you can see. The other example, like okay, let's say you only can solve 999 cm only. But let's say it's 2 meter, then it will show overflow. Then you have to change this one to meter. Then it will show 2.000 meter. Okay, how to do it? You just press these two buttons only. Okay, don't press the auto. Don't press the auto. Right. If you are interested more, if you are interested to this pico ammeter, you can read the lab manual. Okay, that's an introduction in the lab manual. Okay, for battery have two terminals. Commonly, the black wire represent the negative terminal, and the red wire represent the positive terminal. Okay, then the battery can be used to test the functionality of wires before you start the experiment. And the symbol for battery is something like this. The long one represent positive, the short one represent negative. Okay, so if it's a long one, then you have to use the red wire lah. Use the red wire to connect the long one, and the short wire connect to the shorter one. The black wire connect to the shorter one. Okay, this is the symbol for the battery. And the battery will only be used for experiment 1. Okay,